Hey everybody, this is Mr. Walsh showing you how to do the extra credit assignment. You can find the extra credit assignment, or you have found the extra credit assignment right here in the Google Classroom. And so I'm just going to go through the directions here a little bit so that you know what the heck you're doing. Excuse me. So you're going to go to fet.colorado.edu. Okay, that website has a lot of neat stuff on it. But what we're going to do this time is we're going to play with the simulations. Now you're going to scroll down and you're going to find the build an atom simulation. And the whole goal of this is to understand about nuclear stability. And so why this is extra credit is that we don't really have to worry about the nucleus so much, but there's definitely interesting chemistry that can happen in the nucleus, and I wanted to expose you to some of that. So we're going to click the play button, and we're going to see how the nucleus kind of interacts how the protons and neutrons interact and what happens that way. So you're going to make sure that all of these are highlighted here, or checked off. Okay, and then if you really want, you can show the mass number, and then we can go. Now, this has everything to do with the ratio of protons to neutrons. And so what we're going to do is we're going to start with 0 protons, which if you look at your sheet is these numbers down here. And then we're going to add 1 neutron. And if we look, 1 neutron is, just by doing that, is unstable. So the unstable ones are going to be blank. Okay. Now to reset it, we hit this little reset arrow, and now we're going to move up to 1 proton. Now, 1 proton, and we're not going to worry too much about the electrons in this case, but 1 proton, if we look at it, is stable. So 1 proton and no neutrons is stable. So what we're going to do is we're going to make this, we're going to highlight this, and then we're going to shade in this box right here. Let's see if I can figure out how to shade it in with my, let's see, look at this, watch this. Okay, so we can go here, we can go here, and we can shade it in black. Okay, so that means that that one is stable. Okay, now we would add a neutron to this guy. Whoop. Boom. Notice that that is stable too. So we're going to highlight this box. And again, we are going to fill it to show that it is stable. And now we're going to go to 2 neutrons, and that is unstable. So we're going to leave that blank. And then if you want, you can keep adding neutrons. But little secret is after you get to the first one that's unstable, the rest are going to be unstable too. Okay. So now you would do the same thing, and now we're going to start with 2 neutrons. Okay. And look, 2 neutrons in the helium atom, 2 protons with no neutrons is unstable, so we leave that blank. But this one now is stable with neutrons. So you're going to go through and you're going to do all of that. Excuse me. Then the last thing that you're going to do then is you're going to try to figure out what the relationship is between the number of protons and neutrons and how they are stable. So I would definitely show some math and see some of that. And then you're going to use that answer to predict whether these isotopes are stable. So stable nuclear isotopes are found all the time, and they don't go anywhere. It's the unstable ones that are what we call radioactive. Okay, and those are the ones that break down and can be dangerous because as they break down and are unstable, they emit a lot of energy. So that's the interesting part of this, and I think it all has to do with the number of protons and the number of neutrons. So, anyways, I hope you have fun doing this little extra credit assignment and look forward to see what you do.